Generators. A prime generator. A prime number or a prime is a natural number greater than 1 that has no positive divisors other than 1 and itself. A natural number greater than 1 that is not a prime is called a composite number. So let's create a file called primes and let's check how primes works. .py primes.py, and then I will create a prime variable with an empty list. Excuse me. Let's try again. Like this, an empty list, primes, plural. Then I will insert up to equal to 100. Then for n in range, I don't know, from 2 up to +1. Okay. Then say is prime equal to true. So for again a nested for the divisor and mod divisor equal to 0 is prime equal to false, okay, with uppercase. Then break. After that, if is prime is true, primes dot put append and okay, like this. So at the end, just print primes. So we wanna see the prime number from 2 to 100. Let's execute it. I'll say 5 primes .py, and let's check if something's wrong. This is if, because we need a nested for here saying divisor in range 2 to n. Okay. We will execute it each time like this. Let's try again. And you will see the prime numbers from 2 to 100. Okay. So we are evaluating each number from n to up to +1. From 2 to up to +1, each number will be evaluated in this for loop. We're checking if the divisor is equal to n. And mod divisor equals to 0. If it's the case, it's not a prime number. Otherwise, it will be the odds to the primes list. So let's modify how we're working with primes. We can reduce our code, removing this line, and inside of if you can say else, for else, and then you can say just primes like this. Where I will run it again, I will have the same result. That's because if any break is executed at when it's iterated, n value will be added to the primed list. Okay, that's we are wanting for. Switch. In this case, in this example, I want to show you the technique that I like a lot. In many programming languages, other than if, elif, else constructs, in whatever forms or syntax they may come, you can find another statement, usually a switch case, that in Python is missing. It's the equivalent of cascade if, elif, else clauses with a syntax similar to, for example, in this case, JavaScript code. You can see a statement called switch, and we're working with days, and from 1 to 5 a weekday, 6 Saturday, and 0 Sunday. Else in day number is not valid day. It's not a valid day number. So I'm gonna create a switch part in order to compare it with a Python syntax. So I wanna create if from 1 to day number to 5. Okay, if this is the case, day equal to week day. Okay, elif day number equal to 6, day equal to I don't know, Saturday. Okay, elif day number equal to 0, day will be equal to Sunday. Else day equal to empty string rise value error, and I'll say str day number plus is not a valid day number. You should compare them and check that in the Python syntax. There is an extraordinary snippet where you can compare both conditions, those two conditions at the same time. In this case, I'm comparing the number if it is equal, if it's higher than 1, and is in the and in the right hand, if it is less than 5, less or equal than 5. Now let's talk about iterators. In this case, infinite iterators. Infinite iterators allows you to work with a for loop in a different fashion, such as if it were a while loop. I wanna demonstrate this how iterators works in this simple example. Let's create a file called infinite.py. Now I wanna import Iterators, import count. Okay. Then I wanna say for and in count 5, 3 if n is higher than 20, let's break it. Otherwise, just print and equal to let's execute it and just pi dot infinity. Okay, and let's check how it works. You can see 5, 8, 11, 14, 17, and 20. The count factory class makes an iterator that just goes and continue. It starts from 5 and keeps only 3 to it. We need to break it manually if we don't want to get stuck in an infinite loop. Iterators terminating on the shortest input sequence. This category is very interesting. It allows you to create an iterator based on the multiple iterators, combining their values according to some logic. A key point here is that among those iterators, in case any of them are shorter than the rest, the resulting iterator won't break. It will simply stop as soon as the shortest iterator is exhausted. This is very theoretical, I know, so let me give you an example using compress, and this iterator gives you back the data according to the corresponding item in the selector being true or false. I'm gonna create another file called compress.py. So .py. Now I'm gonna import from Iterators compress. Okay. Then I'm gonna say data equal to range 10. Even selector equal to 1,0 times 10. Odd selector equal to 0.1 times 10. So I'm gonna use the compress Iterator. I wanna say even numbers equal to list compress data even selector. In the other case, odd numbers list compress data. Of course, I'm gonna change it odd selector. Then I wanna print odd selector. I wanna print list data like this. Then I wanna know how even data, even numbers value at the end underscore odd numbers. So now let's execute it. Just py compress py, and you will see our result. And now you will know that odd selector is equal to 0, 1, 0, 1, 0, 1, 0, 1, and 10 times. Then data is equal to 0 to 9. Even numbers will be our 0 to 4, 6, 8. Even numbers, of course. In the other case, odd number will be 1, 3, 5, 7, and 9. Notice that odd selector and even selector are 20 elements long, while data is just 10 elements long. Compress will stop as soon as data has yielded its last element. Running this code produces the following. You are looking at the screen. In addition to this, it's very fast and a nice way of selecting elements out of the iterable. The code is very simple. Just notice that instead of using for loops to iterate over each value is given back by the compressed code, we use list methods which does the same, but instead of executing a body of instructions, put all the values into a list and returns it. Last but not least, combinatoric generators. These are really fun if you are into this kind of thing. Let's just see a simple example of permutation. Before all, permutation, also called an arrangement number or an order, is a rearrangement of the elements of an ordered list S into one-to-one correspondence with S itself. For example, log 6 permutation of ABC. We are looking on the screen ABC, ACB, BAC, BCA, CAB, CBA. If a set has n numbers or n elements, then the number of permutation of them is n factorial for the ABC string. Permutation in this case, you are looking on the screen 3 factorial, which is equal to 3 times 2 times 1, which is equal to 6. So let's do it in Python. We are now in permutation.py. I'm gonna import from Iterators, import permutations. Then I wanna print list of permutations. I'm gonna pass ABC. Okay. This very short snippet of code produces the following result. Let's execute it. Pi permutation. You are watching on the screen ABC, ACB, BAC, BCA, CAB, and CBA. Just be very careful when you play with permutation. There are numbers rolled at a rate that is proportional to the factorial of the numbers of the element you are permuting. And that number can get really big really fast.